Good morning. C++ for C programmers. I'm Victor Eickhout. This is the Texas Advanced Computing Center. I hope everyone brought a laptop. Great. And you have a fairly modern compiler, either GCC or Clang something. Because we will going to be doing lab exercises. I mean, you can listen to me lecture, but you get much more out of actually doing stuff. So just to confirm, everyone speaks C. You can write functions, team pointers, structs. Yeah, good. Okay, C++ for C programmers. So let's see if I can find my mouse. Okay, stop coding C. There is basically very little reason, unless someone gives you a C program and you need to work with it. There's not a lot of reason for doing new projects in C. C++ is just as efficient and maybe even better. It is definitely more structured, it is safer, so it's better for setting up a large project, and it has more mechanisms that protect yourself from yourself. This is very important if you write large software. You make it, if software goes over a couple thousand lines, you don't remember precisely what is happening, and so protecting you from yourself is always a important consideration. You want to make sure that certain dangerous things cannot be done, even if it's by you, the programmer. Okay, so stop coding C in the sense that I think C++ is just the preferred language at the moment. There is a second sense in which you should stop coding C. C++ is more or less a superset of C. You have to get into pretty obscure stuff to see where modern versions of C are no longer contained in C++. But basically C++ is a superset of C. And so if you have a C program, it's also a legal C++ program. That is, of course, not terribly useful, but it also means that mechanisms that exist in C, like taking the ampersand for an address and then using the star on the other side of the calling interface to get your whatever variable, that should no longer be done in C. So I'm going to show you things that are still legal, but that you should not do. So we have the morning session and we have the afternoon session. In the morning session, I'm mostly going to show you object-oriented programming and then some minor things that you have to get used to in C++. Object-oriented programming is a great way for setting up a nicely structured project. And that was the big innovation in C++. So to get you used to that, we'll do a couple of exercises. There are new mechanisms that replace old ones. So instead of printf, you're going to be using cout. So I'll show you how to do that. There's nothing deep there. You might even find it a little more cumbersome than printf. Strings are no longer character arrays, so I'll show you what actual strings are. Arrays, there is a mechanism that sounds like it should have overhead, but basically no, it's just safer. So no longer malloc. Maybe you know that in C, malloc has been replaced by new. You also don't do new. Pointers are definitely, so that will be the last topic of the morning, first of the afternoon. Pointers, C doesn't really have pointers, it has addresses. C++ has pointers and they are very cool. So, you know what a memory leak is? A memory leak is you have mallocked memory, but you haven't freed it, but the pointer to the memory has gone away. And so there is this memory where the OS thinks this program is using this memory, but the program has lost track of it. That's a memory leak. Complicated programs pretty quickly give memory leaks. Well, C++ has a pointer mechanism where it actually counts how many people are pointing to a block of memory, and if the last pointer goes away, the memory gets deallocated. So this is much better than garbage collection, the way Java and Python have it. And it's much better. So it's unlike garbage collection, it doesn't all of a sudden take over your CPU at a time when you don't want it. So it's more efficient. But unlike C, it prevents memory leaks. So it's also more efficient than that. So other new mechanisms we'll get to in the afternoon. Exceptions, that's a way of dealing with errors in your program. Namespaces, if you develop a large program and you want to prevent the fact that I have a routine called foo and there is another routine called foo that happens somewhere else in the update. So you have a data structure for your finite element grid and you want to have a function update for the grid. You have a data structure that stores whatever, and you want to have a function update for that. How do you get them separate? Okay, namespaces. Closures, that is really cool, also known as lambdas. So they are like a better way of dealing with function pointers. And finally, templates, and maybe let's see what does it say in the table of contents? Smart pointers, namespaces, template exceptions. Iterators, those are really cool. And auto and casts. Right, so you know what a cast is in C. It is, here is a piece of memory, and I know that it's really an array of integers, but now I'm going to pretend it's an array of doubles. So basically, there is a piece of memory and I'm going to say what it is. Casts in C++ don't work the way they do in C, so I'll show you a better mechanism. 3 items of iterators, those are really cool. Suppose you have a collection of things and you want to iterate over them, but they're not stored in an array. You can make your own iteratable objects. About this course kind of came about because I was writing a large C++ project and because here at TAC we teach a number of academic courses. So absolutely forever we've been teaching parallel programming in MPI and OpenMP. We teach that every spring. As an academic course on the main campus. So if you're a graduate student, you may want to check it out. Then 10 years ago or so, we started teaching a scientific computing course, which is tools and general background knowledge about scientific computing. And then we discovered that before people could do parallel programming, they actually needed to learn programming. So I don't know, 5, 6, 7 years ago, we started teaching Introduction to Scientific Programming. And I've been teaching that for the past couple semesters. And I've been writing an open source textbook for it. And so these slides are cut and paste from my Introduction C++ course, plus some advanced topics. Okay, so this textbook, you might find it entertaining to download. It contains actual sentences as opposed to just slides. Jason, how many people do we have on chat? Or how many people do we have online?
28.
Okay, that's decent. The C++ language has gone through a number of incarnations. So by default, I think you get the, I'm not even sure, you get the 1998 standard or something. Um, but then in 2011, the standard got a major update. And so the 2011, I'm basically assuming 2011 as the basic standard here. Unfortunately, your compiler does not accept that. Let's see, did I alias this? No, I didn't alias it. Okay, so it's probably a good idea to, whatever your C++ compiler is, to do alias G++ is G++ minus, is that a double minus? It's a single minus. Standard is C++, and let's go for 17. So the C++ Standards Committee has sort of decided that every 3 years they're going to update the standard. So 11 was a big one. 14 is just a couple of patches on the 11 standard. 17 is a big one, and because we live in 2018, you can't really expect the compiler writers to have added everything in 17. So there is a topic that we're not going to get to today, which is supported in the GNU compiler, but not yet in the Intel compiler, which is a shame because I like it. Anyway, so 17 is a pretty decent update, and if you search online, you can find already what is going to come in the 20 standard. Okay, so basically tell your compiler to use 14 or 17. Okay, a couple of minor things, meaningless stuff. So C++ has a Boolean type, so you don't any longer have to use int for truth values, and then what is it? 0 is false, and anything else is true. That's kind of ugly. In my younger years, I worked on a compiler, and they figured, okay, if you test is 5 equals 5, well, subtract the 2 from each other, and so 0 is true, and anything else was false. So there is no logic why 0 and 1 should be true and false. So C++ has an actual Boolean, so if you have truth values, please use bool, not int, and use true, false. Oh, I just realized that there is something that is not in this presentation. Relating to logicals, you don't have to write vertical bar for and anymore. There is AND, and there is OR, and there is NOT. That is not yet in this presentation. I should add that. So your logical operators have suddenly become readable. Single line comments. So you don't have to enclose your comments in /stars. You can // means ignore everything till the end of the line, so that's nice and compact. And very useful, the loop variable can be local to the loop, so you don't have to declare your variable outside the loop and then maybe by mistake use it somewhere else. If your loop variable only has meaning inside your loop, do it like this and define it inside the loop. I/O. Okay, so instead of include standard lib and include standard I/O, you do include I/O stream. So these 4 lines basically go at the top of every file that you're going to be writing today, maybe with 1 or 2 lines more. So this is basically like standard I/O. Include I/O stream, and then using standard cin, standard cout, standard end of line. So the way to do idiomatic I/O in C++ is to use cout. Printf still works, but cout is kind of the idiomatic way, and it has advantages. So how do you write that? Cout less and then there's a string, and then there is less, and then you get an integer, and then less, and another string, and less, end of line. So if you want to print a number of things, an int and a float and a string and another string, just string them together, pun not intended, with less's, and so you get a C outline like that. Right, the C stands for console, and likewise there is a console in. So accepting input from the command line. This has its limitations. You can only, if you want to input a string, there cannot be spaces in it. So there are better ways of doing input, but for simple examples, this works fine. So cn into a variable C out from data to the console out. Yeah, so using, if you look at C++ code online, you will often see using namespace standard, which is shorter, but it's very dangerous. I ran into this in my introductory programming class. If you do using namespace, then all of a sudden thousands of functions have been defined for you. And so if you want to use one of those functions, then you stomp on what's already there. Or maybe you're using the function and you actually forget to define your own function, but then you get the one from the standard library. So by using namespace, you can get very obscure bugs that may take you a long time to track down. So I ran into it in this beginning course because I was telling the students, write a swap function. Well, swap is defined in the standard library. So if they make a typo in their own swap function, and then they call it, they get the other one. And this is really confusing. Anyway, but just warning you. Standard header files. So C math is one that you will regularly use, in fact, in the exercises here. If you insist on including some of the old C header files, they are usually available as not standardlib.h, but C standard lib. But the whole header structure has changed a little. By the way, if there are questions, please raise your hand. I see that no one on chat has any questions yet. Okay, so we're going to look at functions or subprograms or whatever they're called. So there are small changes, there are big changes. There's a couple of small changes that we'll get to. So you can have default values on parameters. That is quite convenient. You can have polymorphism, so you can have two functions with the same name, and as long as their input parameters are sufficiently different, there is no conflict. The big change that I want to devote some time to is I'm going to show you how to use references instead of addresses. So have you heard of pass by value and pass by reference in C? Well, C doesn't really have pass by reference. C++ has real pass by reference. Okay, parameter passing. So it's a good programming practice to write mathematical kind of functions. So you write a function where data goes into it and the only result comes out as the return parameter. That is sometimes called functional programming. It's a nice and clean way of programming because it's completely clear what changes. So you write y is f of x, and you know that only the stuff on the left side of the equal sign gets changed, nothing else gets changed. So it's side effect free. Pass data, return. Right, so in a programming language, if you call a function like this, data gets copied into the function. So what if you pass a large structure? Yes, it gets copied. Okay, so pass by value is sometimes a bad idea because lots of data may get copied. Anyway, this is pass by value. You can also write functions where maybe you're not using the function result, or the function result is a status parameter, like this computation succeeded. For instance, you could have a square root function. And what happens if you stick a negative number into a square root function? Should your program abort? So you could, for instance, make your square root function into a Boolean function where a Boolean comes out that says, yes, this succeeded, and the result gets returned through the pass by reference of the parameter. So third bullet point, return other information by changing parameters. So that's how you learned how to write functions in C. You put an ampersand in the main program and you put stars in your function. And you call this pass by reference, which is not really pass by reference. Okay, so depending on how a parameter functions, you can call it input if it only goes in, output if it doesn't need it to have a value when it goes in, but it does have a value when it comes out, and throughput. So in C and C++, there is no way to distinguish between output and throughput. This line is mostly here because it comes out of my programming course where I also teach Fortran, which does have explicit designation of this is out or this is in-out. Okay, C++ references are different from C. C does not actually have a pass by reference. It passes an address by value. So by writing ampersand X, you get the address of X. You tell your function, okay, here's a memory address, just put something in it. So it's not a pass by reference, it's pass an address by value. C++ has actual references. In fact, they use the ampersand character, but differently. Asterisks are out. If you find yourself writing asterisks, you're not writing C++. Okay, in a couple hours, I'll show you that asterisks may still be used, but basically for function parameters, no asterisks anymore. Okay, so what is a reference? A reference is not an address. A reference is an alias. It's a synonym. So two names really refer to the same object. Okay, so in all these slides, I'm going to have, it says code and it says output. So this is clipped from a main program, and then here is the output. Any of you use LaTeX? I hope everyone uses LaTeX. MS Word is evil. Do you know what write to 18? Write 18 is, someone made an extension to LaTeX where you can actually run shell commands during formatting. So my output is guaranteed correct because this program is run while the slide is generated. My macros are somewhat on the sophisticated side. Okay, so what we have here, we have an int I and then an integer ri, where r stands for reference. The crucial bit is there is an ampersand. So int ampersand means it's a reference to an integer. And so ri becomes a reference to I. This is not the same as int star. Ri is now really the same object as I. So I set I to 5, and I see out I and Ri, and I get 5, 5. Okay? I is 5, R is basically the same thing as I, so I output I and Ri, I get 5, 5. I multiply I by 2, same output, I get 10, 10. I subtract from Ri, same output, I get 7, 7. So you see that the two variables are both used as is. There is no, in C this would be int star Ri is address of I, and then you have to write star here every time. So it's different, it's not an address. The two names really refer to the same thing. Okay, this example is just to introduce references. I cannot think of a useful application for this. The more so because you cannot redirect Ri. It's stuck at I. So it doesn't behave like a pointer in that way either.
I have a question about references. How does the compiler implement references? Are they actually pointers internal or addresses?
Well, internally in the compiler, the variable is an address. There's a table that says the label I corresponds to this address, and then it says that the label Ri is also that address. So, yeah, is how I imagine. There is a question in chat when Ri is not initialized to I. Okay, that's the point I was just making. Previous slide. You cannot have an uninitialized reference variable. When you declare a reference variable, you immediately have to attach it to an I. To a other variable. Good question, thank you. Thank you, Mr. Chat. So where references come in is Alex, thank you. So where references come in is in function calling. So so this is a function that is going to change something in the main program. Now in C you would write function and then the address of I, so ampersand I, and you would have an int star in function definition. Here you specify your function, so your variable goes into your function, and then in the definition of the function you say that n is not copied, passed by value, but n is a reference to whatever the actual argument was in the main program. So this is a mental shift with respect to C, but at least you recognize that you don't have to write star n in your function, right? So it's, your function becomes a lot cleaner. The one objection that everyone always has is, but now in the main program, I don't see if it's being passed by reference. Yeah, sorry, that's true. Anyway, so the function definition has an int reference, which means that the local variable n inside the function becomes a reference to whatever it was in the main program. And is it possible to redefine a reference? No, it stays stuck on that. But the example that I gave with references in the main program, I've never seen any useful use for that. It's just to introduce the notion of reference. Okay, so example, pass by reference. I have a function, it gets a ref int, which it sets to 5. My main program sets var to 0. It gives it to function f, and then it outputs it, and miracle of miracles, it becomes 5 in the output. Okay, so this is an example that I described in the abstract about 5 or 6 slides back. You have a function where you want to do something with the parameters. You also want to return a result. So in very metaphoric, almost pseudo code, I want to have a function that reads something from file, but it also gives an error back if it was not possible to read it from file. So I make that into a bool function, and it gets a reference to an int. So so file status is try open file. If the file status is 0, then I can read from file. Otherwise, so okay. So if it's possible to open the file, then value becomes read value from file, and I return whether the file status was successful. I should rewrite this example using booleans throughout. Anyway. You get the idea. So it tests whether it's possible to open the file, and if so, it reads from it. And then you can use this function as if I cannot read from file, then I give it some default value. Otherwise, n gets its value. Okay? So this is an example why you would not use the functional style of programming. The question in chat about how it was implemented has been answered in class. Okay, let's do an exercise. Write a void function swap ij that exchanges the input value, just to make sure that you know how to do this stuff. Okay, open your editor, compiler. Mute the microphone a little bit. Okay, I saw someone using this syntax. The C++ has too many ways of initializing variables. And then C out. Okay. Everyone know what I just typed? What is the ampersand ampersand? Yes, it's a logical and. So basically it means if this fails, then that is not done, or if this is successful, then the next command. So you don't want to write. Come on. You don't want to write this during program development, because if your compiler fails, the program is still run. So yeah. Okay, let's repair my. Anyway, doesn't matter. Okay. Oh yeah, so there are optional exercises for people that are very fast in solving the first one. Okay, so references. So that's the first big change, the big difference with C. Small differences. You can have default arguments on functions. So your final, however many arguments, can have a default value. So for instance, the function double distance of two parameters x and y gives you the distance between x and y. And if you specify only one parameter, then it's using the default for the next. So it's distance to the origin. Not a terribly deep example, but you can see that, for instance, I have many functions that have a final parameter trace, which is always false. But then if I debug them, I set it to true, and it activates trace statements. Okay, default values. Polymorphic functions. You can have multiple functions with the same name as long as they look different enough. The compiler is perfectly happy with this. So the sum of two or the sum of three numbers. Okay, in C, the keyword const already appeared. C++ does much more with const than C does. For instance, if you have a function with an int I parameter, then it's passed by value. But inside the function, you can still make changes to your variable. It's perfectly legal. It's just that it has no effect to the main program. If from the logic of your program, you really want that variable to stay const, then you can say it's a const int. And so now that function is illegal because it says it's a const int. You cannot change it. Again, it's a way of protecting you from yourself. We'll get into const later in more serious ways. Object-oriented programming. So I hope everyone still sort of remembers what structs are in C. A struct is a way of bundling some data together. So suppose in your finite element mesh, your points have an X and a Y, and you want to give them a numerical label. Or whatever. So you can bundle together two doubles and an int into one struct named numbers point or something. So that is bundling data together. You can look at a function as a way of bundling instructions together. So you have a whole bunch of instructions, and all of a sudden they get one name, like update grid or interpolate function. So classes and objects can be considered as a way of bundling both data and functions that work on that data. So initially a class, class is what you write once, and it describes what an object then looks like. So you once write class, and after that you can create many objects of that class. So class vector has a X and a Y, and this is almost the same as saying that a struct vector has an X and a Y. So now in your main program, you write vector P1, and then you use the same dot syntax that you're used to access the X and the Y that are in your vector P1. Okay, this is not a good idea. We'll go into details later. Yes, you saw the keyword public here. So in addition to public, there is also private. So a better way of setting up a class is to make all your data private and then have functions that are public. So the functions are what is used in the main program or anywhere outside the class. Okay, in the previous slide, you saw that I just wrote vector P1, and that created a vector for me. Here I write vector P1 and then parentheses 1, 2. That is not an initialization. In fact, this looks a little like a function call, right? P1 and then function arguments in between parentheses. Well, that is because it is a function. Every class comes with one, more than one, but for you guys right now, one function predefined, namely the constructor. So as soon as you have a class vector, and as soon as you write vector v, it calls the constructor function. So it's more than just allocating the data, it can possibly execute some code on it. Okay, what is a constructor? A constructor is a function that has the same name as the class. So you see class vector, and then in the public section, there is a function vector of double x, double y. Note that it's not a void function. The constructor is the only function that does not have a return type at all. Okay, so the function, the constructor function takes an x and a y, and what does it do? It copies the x and the y into the vx to vy. What is the vx? Those are the private data members of the object. So what are you doing here by having vector p1 with parentheses 1, 2 in your main program? You're creating a vector p1, and the values 1, 2 are copied by the constructor into the private data members. Okay, that's the constructor function. So I declared my data members private, and all of a sudden, the main program can no longer get at them. The compiler says this is inaccessible. So what do you do to get at your data? Well, you use so-called accessor functions, which are functions that get at your data. So there is one step in between. Why would you do that? We'll get to this. Two-column layout. So class vector has a private vx and a vy, and it has a constructor that takes the x, y, and puts them in the vx, vy. There is more public functions to this class. Namely, there is a function x which returns the x value. And there is a function y which returns the y value. So these really return the value. They don't give you access to the internal, it's just the value. So typically you will also have a function set x, which accepts an x and it copies it into the vx, and likewise set y. So now you can have in your main program, you have your vector p1, and then you do p1 set the x to 3.12. By the way, note that the function x only gives you the double, so it's illegal to write p1's x is 5. That doesn't work. That is like writing 3 equals 5. Occasionally there will be a slide that doesn't entirely fit, but you can still read the last line. So I set the x of p1 to something, and then I cout it, and I use the function x to get at the data. Okay, so accessor functions are the safe way of dealing with private data. There is a question from Alex, and Alex, we will get to that in a second. Okay, public and private. So the implementation, you want to keep your implementation like precisely what data you store private, and public is the application programmer interface. It's how your class is being used. So you need to decouple how you store it and how you use it. Having this separation of public-private is also a way of, again, protecting yourself from inadvertent changes. And another way is that your function, your function x stays available even if you change your mind about how to store a vector. If you decide to not store your vector as an x, y, but as an r and theta, you can still have your function x. So for the code that uses the class, nothing changes. They can still say, okay, give me the x coordinates, while you have made a design change, and instead of storing x and y, you store r and theta. Okay. I answered that question. We'll get to that in a second. Okay, as an example of why you want to have accessor functions, suppose you have a class that does not just model a single xy point, but an xy point on the unit circle. And so you create it from just your x, and then you have a function set x, which copies the X value into the X that you store, and it computes the Y value. Now, suppose that I had made my X and Y public, then it would be possible for code outside this to make a change to Y and forget to change X. And all of a sudden, something that I think is on the unit circle is no longer on the unit circle. Okay, so think of it this way. An object models something that exists in some sense, and there are properties. If you're a physicist, conservation laws. So you want to make only changes so that your conservation laws are satisfied. You want to make only changes that preserve certain predicates on your data. That's kind of an abstract point, but since you guys have already been programming, I hope you sort of appreciate this. Default values, if you can put default values on your any data members. Did I emphasize? I used the word member or a data member for data and method for functions that are defined inside the class. Oh, I didn't stress this. That is actually fairly important. You see that I extend the dot notation to functions. So with structs, you could say P1's X, but now with classes, your vector object has both data members and it has functions, and so you can call the function on an object. So that's an extension of the dot notation. There is more ways of initializing data. There is this weird syntax with a colon, and so now this is the constructor. This is the constructor, and that was what copied the outside data into the private data, and you can use that with that notation. That's called a member initializer list, which is a confusing name because there are also initializer lists, which look completely different from member initializer lists. And there is a certain advantage. You can have some name overloading here. See, a vector has an X and a Y, so it would be so convenient if you could just write X and Y. Why do I have to come up with new names? Well, well, otherwise you couldn't do that copy, right? But with this weird syntax after the colon, this is the data member, and then in parentheses, it gets what comes in from the constructor arguments. The functions get X and get Y are as they were before, I guess. Anyway, so this is kind of an interesting syntax. And to foreshadow the future, this is actually, it saves you one copy operation if your data members are themselves objects. So with doing the copying inside the constructor, there is an actual copy. Here there is no copy, data gets moved. If you get very advanced about C++, then you start hearing about move semantics. We may very briefly touch on that later. Anyway, so C++ is kind of a complicated language, but that is because they want to make sure that you don't copy unnecessarily. And so there are a number of constructs that save on copying cost. Okay, so I just showed you member initializer list. Here we get initializer lists. So in the swap program, see how I initialize the variables. This is this in between curly brackets. It's called an initializer list. And you can use them with classes and objects. So if my point class is defined, if the constructor takes two floats, then I can actually write, instead of having it in between parentheses, I can have it in between curly brackets. And this curly bracket notation can even be used as a shorthand. Okay, let's walk through this code. So I have a point class which takes 2 points. So obviously a point is an x and a y coordinate. So this is how you construct a point. I have a rectangle class, and a rectangle is constructed from 2 points. Awesome. Okay, it's an axis with an axis parallel rectangle. So if I have the bottom left and top right, or for you guys, bottom left and top right points, then I have a rectangle, right? So bottom left, top right. Okay, and now I define a point origin like this, and I have a rectangle lie low, which is between the origin and, oh, what is this? The rectangle is defined with 2 points. This is clearly a point because I defined origin as a point. What is this? Well, so the curly brackets is an initializer list, and it can actually be used as a shorthand for a point object. So the rectangle knows that in the second position there needs to be a point, and so you can use the initializer list. I'm sure that 5 minutes from now you'll forget this, but read through the slides again when you come home. I'm kind of covering stuff at an accelerated pace because you guys are already programmers. Okay, we are nearing the next exercise. Yeah. Okay, so far we've only had very trivial methods in the classes. Let's do something serious. So let's have a vector class, and I want to know the length and the angle of the vector. I've been lazy, so the angle function is not actually implemented. Anyway, so let's look at that length function. The length of a vector is the square root of the sum of squares of the x and y. So I have a class vector. There is a function length, which is inside the class. And so in the main program, if I have a vector, I could say P1's length. The function length has no arguments. So imagine what this would look like with structs. If you work with structures instead of classes, then you would write length paren open of your struct, whatever. Here, so at a minimum, using object-oriented programming is flipping that syntax around. Instead of function on data, it's data function. Yeah. So because the function length is defined inside the class, you can now apply it to something of that class. How is this function defined? It says return square root of a whole bunch of stuff that is not in the arguments, and it's not locally defined. So where does this come from? Well, it comes from here. So the methods inside the class consider all the data and other methods of the class as global. So no matter whether it's private or public, the Vx and the Vy are global variables for the functions inside for the methods that are inside the class. So that's how you do the length, the angle. I should just really write a tan of y over x, because that, yeah, I think that's it. Okay, internal functions are called methods. You get the dot notation for calling them, and all the data members are global to the methods. Alex has clearly seen this stuff before. We'll get to this later. So what I was just doing is object-oriented programming in a way. So I have these functions that return a result, but I can also have functions that alter the object. So with my vector class, the way I defined it before, I can have a void function scaled by, so scale my vector by a double. And what does that do? It multiplies the Vx and the Vy, which are global to the function. And so all of a sudden my vector changes, as witnessed by the main. See, it's void. It doesn't return anything. It makes changes to variables that are global to that function. So I make a vector 1 and 2, so that makes square root of 5. P1 has length. Look at the output on the right. I guess that is square root of 5. P1 scaled by 2. I have the same output statement, P1's length, and it's now square root of 20. Okay, so it is perfectly fine to have methods that alter the object. You can have methods that create a new object. So suppose you want your scaling function not to alter the object, but to return a scaled object. Look at the main program. P1 has length something. P2 is P1's scaled by 2, and then it has length something more. How do you write that? Well, so your function scale works on a vector object, and it returns a new vector object. So you see the return type is vector. Scale, it takes an A as input, and what does return vector with initialize that? Okay, this is very compact. It may look a little like magic, but I hope you see all the bits. This function is inside this class, so it knows Vx and Vy. A comes in as an argument, and then it creates a new vector with the scale x and y components, and that is being returned. So the return type is vector, and so P1 scaled by whatever gives you a new vector which is assigned to that. Okay, you like my song and dance?
Of the two ways of doing this, the one returning vector and the one modifying it, is there a preferred style?
No, it's you need to. It depends on the structure of your code. If you know that you're going to be working on temporary objects, then you want to scale it internally. But if it's an object that needs to be preserved, then you want the other. So it's really a design decision.
Okay.
Exercise. Make a point class. And then there will be another exercise that builds on this. So just to get you typing this stuff to
answer Alex's question, you can do this right now and figure out if he has to declare coordinates or not. Because you're setting up a default or a default constructor that requires input. You know, an X and Y coordinate. But then if you just try to say point and then assign a variable P,
that slide comes in.
The compiler will freak out, right?
Yeah, so the answer to Alex's question comes in 3 slides.
Yeah. If you're going to declare a default constructor, you can't just
If you declare explicitly constructor, then the default constructor gets undefined, and so you need to redefine it.
And I think you can do like a default something in C. Like in a more recent version of C, I think you can specify default for C++. 2008.
Not sure about that one.
Yeah. Oh, C++ 11. It looks like you have the option to specify a default for your constructor.
Yeah. We're getting increasingly into,
Yeah, we're in the weeds at this point.
yeah. Oh, 30, 40. Yeah.
Then inside the point function. Did you see
Well,
that one?
this is not correct. Yeah.
Okay.
So the constructor is a function. So it's name, paren, and then type name, comma, type name. And that doesn't look correct. Okay, now it's correct.
No.
So the only way to get that is remember initialize.
Okay, I think we can do that.
So you have your, class point, private float xy, public point float x float y xx y. So you sort of want to make this work. Okay, so distance is first of all a float function because the distance is a scalar. So what does it operate on? Well, it's the distance to another point, so you clearly need a point other. And now, how do you compute this? Well, distance is the square root of the x's plus the by the way, what I'm doing here is something known as top-down program development. I started with writing the main program, so this is what I wanted to look like. This is what I consider to be a nice design. And now I'm filling in the details. So you saw that I wrote the distance function and I had an empty function body and now I'm filling it in. So I know that the distance is the root of the sum of squares. And so I go down one more step. Okay, now we get to the crucial bit. What is dx? Well, dx, that is my x minus the other x. Well, in fact, that is pretty easy to write. You can write x, which is mine, minus, okay, what is the other x? And you can, in fact, write it like this. This will probably work. Now, if you had defined functions, float get x, return x, then you could have also done that would also be the okay, so these are two different solutions. Now, so someone do it as follows. Oops. If you have the function distance to origin, then you can also write it like that. So the distance between me and another point is the same as shift me down by the other point and then do the distance to the origin. So I take me, x, y, and I shift it by the other x and y. I make a new point from this, and then I do the distance to the origin. So this creates an anonymous point. You create a point. This is calling the constructor. You're just not assigning it to a variable. You're using this point, and it doesn't have a name, but it is a point, and so you can do its distance to the origin. Yeah, so the only reason not to do it like this is if constructing a point has an amount of work associated with it, then this is a little extra work. But it's otherwise a perfectly valid. Okay, there is a question on chat, which I privately already addressed with one of you. Okay, so the concept of private, you can sort of consider that to be private to the class, not private to the object. So you may notice that point has a private x and a y. So in the main program, you cannot get at the x and the y. But if you are another point, then you can get at the x and the y of any other points. So x and y is really private with respect to the class, not with respect to an object. If two objects are of the same class, then they can get each other's private data members. Okay, that was exercise 4. Yeah, well, if you're very fast, you can do exercise 5. Something about the default constructor. So I defined a vector class that had a constructor that took 2 floats or 2 doubles, whatever. And now I write, okay, what if I write vector v1 and I give it indeed 2 real numbers, and I write vector v2 because I don't know what v2 is yet. I later want to say v2 is v1 scaled. If you have only one constructor, if you have the constructor from 2 floats or doubles, then you get an error message which differs for a compiler. For G++, I get this message that on line 32, character 21, which is the v2, it cannot find a function that looks like vector vector. Okay, so what does that mean? Before double colon is the class name, so it looks for class vector, and then it wants a function vector with no arguments. Well, yes. So vector vector, that is a constructor. So it's looking for a constructor with no arguments. Okay, that's correct, because I defined the constructor only with 2 arguments. But here, look at this v2. You cannot just write v2 and say it will become something later. C++ sees vector v2, and so it will immediately call a constructor. Because there's nothing after this, it will call the default constructor, which looks like no arguments. But as soon as you define a non-trivial constructor, the default constructor goes away. Okay, so how do you solve this? Well, you define 2 constructors. So in addition to your constructor that you have, you define a default constructor. So this is the polymorphism. You have 2 functions that have the same name, but as long as the arguments look different enough, C++ has no problem with it. And so here you're calling a constructor with 2 floats or 2 doubles, and it will use this. Here you're calling a constructor with no arguments, and it will use this one. Question in class?
Yeah, so when you do that, the actual members associated with that class, the data associated with that class is undefined, correct?
Correct, it's undefined. So which is fine because V2 will get a value in the future because you scale another object, or you can use default values on the data members.
Yeah, so if you don't specify default values though, and you try to do like a V2 dot
Yes,
A, then you can
if you have no default values on your data members and you do not set it, then you have an object and the data members are whatever happens to be in memory. Maybe your compiler zeros it for you, maybe it doesn't.
So it'll pull whatever that memory reference is.
And that happens even if one of your members is an object itself?
If one of your members is an object and you use the default constructor, then it calls the default constructor on that object member.
So only the ints and floats and all of that is undefined.
Oh, right. Those are random memory.
Okay.
The other one, it will call the default constructor. Yes. Okay. Oh, let's do a cute exercise. So C++ objects can, of course, be things that are sort of tangible objects in the real world, like a point or a rectangle, something you can point at. There is one. But you can also make objects for much more abstract things. If you're going to be writing your finite element code, maybe you will write a class of operators so that gradient becomes an object. So you can have objects that are something pretty abstract. Okay, let's write an object that is a prime number generator. And so I made the point that when you write classes, you have to think separately about what you store and what you make accessible as functionality. So clearly, I cannot store all my prime numbers. So I have to store something else, and I have to worry about how is my prime number generator used. Okay, well, in this case, I want to find all prime numbers in sequence, and so my prime number generator has exactly one method, next prime. Okay, and how do you do this? Well, you have the data member last prime found, and so the next time you call next prime, it searches a little further. Whoops. All right. Let's give a very simple example to inspire you. So I'm going to make an object that models all the integers. So I define a class stream. It remembers its last result. And it has a function next. Note that there is no constructor. I'm perfectly happy with the default constructor. And so the function next is increase the last result and give me the value. So now I have a main program. I create a stream called integers, and I do int next, int next, int next, 3 times the same call. But every time I call this function, it increases the private data member. So that's called it has state. This object int has a state. If you call a function without any arguments, it still changes the internal state. Okay, you call it 3 times, you get 0, 1, 2. Okay, so take that as inspiration and start doing this exercise. Write a class prime number generator, or prime generator, that has data members. How many primes have I found? And it has a data member last number tested. There should be a method next prime, and there should be a method number of primes found. You need to write a function is prime, which I'm sure you guys can do within 20 seconds. Anyway, I want you to write a main program that looks like this. Cin, number of primes, prime number generator, and while sequence number of primes found is less than the input, then find the next prime and print it out. Okay, 10 minutes. By the way, we started at about 9 plus epsilon. It's now 11 o'clock, so feel free to, I'm going for a stroll for 10 minutes, so we have a break. Where is the Zoom chat window? Oh, it just disappeared. We're back. Yeah, I'm good. Okay. Okay, did everyone manage to get this working? Oh, stuck on what?
So I'm not really visualize where to start, but we didn't show you.
Oh, you can set the default value in the class. Show me your class definition. Prime. Next prime. Okay, you're still in a very preliminary state. How are you doing? You're working on the point exercise.
Yeah, we're working on the previous one.
Yeah. I want to discuss this exercise. How are you doing? Yeah, that was decent. Prime. Next prime. Do I have notice prime? Next one. Return. Yeah. This increase is never done because it comes after the return. The return statement, you need to split those two statements. Otherwise, it looks good. Yeah, your prime test, and yeah, your class. Okay. Let's see. I don't want to type out the whole solution. Prime.cxx. So we need to have a class prime generator, which has to remember you have to, let's see, the first time you call it, you want to generate 2, so you probably have to step your last tested started at 1, and how many found is 0. Public. So I don't need a constructor because the default values are all fine. So I mostly need my method next prime. Oh, and of course I need a bool is prime int I return I'm lazy. So the next prime that should be so while you have to increase the last tested by 1, and if it's prime you return it. So while not is prime last tested, give the and then increase it. Hey, don't you love that? Oh. A while loop with an empty body. So the while loop ends if it is prime. While it's not prime, increase. So that ends when it is prime. So then you found one, you can return. Okay, that looks decent to me.
Shouldn't be plus last tested?
No, the plus is in the
Yeah, that's what I mean.
here. So while it's last, so this is short for while last tested is not prime, do last tested plus. So while it's not prime, increase it. But that means that after the while loop, you have found a prime. And so you return it.
But it has been incremented +1, right? Because you tested the previous one and it didn't do it. So it did the last tested plus, even
Okay.
though.
Let's say we're at, we have just delivered, so the invariant is that either you haven't found anything or last tested is a prime. So if you haven't found it, so last tested is a prime. So, or you haven't found anything. So let's say it's 1 initially.
So the first time you call is prime.
Is prime. So 0 is, so 1 is not a prime. So it increases it. 2. 2 is yes a prime, and so it returns 2.
But now you have incremented it to 3, right? Because the last tested is not inside the for loop body, it's in the condition.
No. You're testing 2 and it increases it to 3. You return 2. The next time it tests, is 3 a prime? Yes, it is. It returns it and then it's 4. Okay, so the invariant is that last tested is 1 more than the last prime that you found, or you are at the initial condition.
But then you return 3, right?
3 is okay.
You want to 4.
Okay, so 4 int j less than I j plus plus. 4 int j is 2 j plus j less than I j plus plus. If I mod j is 0, return false, return true. Do you think that's a prime number tester? Um, Why, what is it complaining about? Oh. Okay, I'm probably off by 1 somewhere.
I think it's the plus. Maybe I may be wrong, but.
Oh, you're right. Yes. It does 1 too many. I see your point. How about this? Transposed errors are always, hey, thank you. Okay, anyway, so this makes the point that classes have an internal state, so you can update them repeatedly. And classes can be somewhat abstract. Okay. So I showed you a couple of classes that had a accessor function x, which gets at the internal x. And they only gave you a copy, but now you can define the function as returning a reference. So now whatever vector object v's x is not the value, but it's a reference to the internal thingy. And so now you can do v's x is 3.1 because this is no longer a double, it's a reference to a double, and namely it's the reference to the internal value. Okay, so this makes it dangerous again because now you can get at your internals. On the other hand, it's an API. Okay, so you've only seen references up till now as a way of giving parameters to a function. But in the context of classes, it can be useful to give a reference to internal data. Why would you do that? Well, suppose your internal data is some big object. Normally, if you do return, it copies the value to the main program or to the calling program. And copying can be expensive if this is in a computational loop. So by returning a reference, it's no longer a copy operation, but you're referring directly to the data member. Now, of course, being able to access the internals directly, so by giving a reference, it becomes cheap to access it. But as I pointed out half an hour ago, it's dangerous to be able to do that. So that's why C++ is full of const references. So okay, you don't yet know what a vector is. Just pretend that it says array. So you have your point class, which contains a good amount of data. Now you have a grid class that contains an array of points. And suppose you want to be able to get at that array, for instance, so you have your grid, and you want to get the points, and then you want to access one of the points in the grid. So you don't want to have to copy your whole array of points. And so instead of, so points is a function, it gives you the internal array. So the return type is array of points, but to make it cheap, you turn it into a reference. And now in order to prevent the outside environment from tinkering with data that should be protected, you make it a const reference. So a const reference is a reference, meaning there is no copying involved, but by consting it, you prevent inadvertent changes to the object. Okay, so in C++, you could also put a const on the star, and then you had to think, is it an int const star, or is it an int star const, or is it a const int star? And I could never remember that. So, and this is much cleaner. Okay, in chat, someone asked about this. So if you're inside a object, you can actually get hold of yourself by using this. This is a pointer to yourself. If you've programmed enough pointers in C, you'll recognize the arrow notation. It's dereference and then take a member. So this is a pointer to yourself, and so you dereference it, and then you can get at your internal components. This use of this is not overly useful. Where you need this is okay. You have some class So let's say you're inside a method, and now you want to call a function that works on that type of object. Okay, so you have some class, you have a function that is not inside a class, but it's just a function, and it takes a class object. And now inside your class, so this is a forward definition, otherwise you couldn't write that. So inside your class, you have a method, some method that wants to call the sum function. So you have your method, it works on, it belongs to the class object. So let's say your class is a finite element grid or something, and you have a function that computes the norm of a grid. And that function lives outside the class. So you want to flip the normal notation where you say object dot function. So now you need to be able to get hold of yourself so that you can pass it to a function. So you use this. It is sometimes useful. In addition to the constructor, there is the copy constructor. So if you have an object, it's very easy to make a copy of it. I define a class here that is called hasInt. So it's a class that stores internally an int, mine. And so the constructor takes an int, and why all the print statements? Well, on the next slide, I'm going to show you what the output is. And so we're going to trace the workings of this thing. So the constructor will output, I set something. This is what a copy constructor looks like. It looks like a constructor because it has the same name as the class. But instead of having an int or something, it has the class name again as an argument. So that means if you have an object, then you can make a copy of it. For obscure technical reasons, for technical reasons, the copy constructor cannot just work on an object, it has to work on a reference to an object. Okay, and so so it's a constructor, so it makes a new object, and it does that by taking the other object, taking its internal data, and assigning it to your local data. The copy constructor also makes does a print statement. And then there is a print me function that prints out the object. Okay, so the output statement will trace the workings of this. This is called a copy constructor. It's defined by default, and so the only reason that I define it is because I want this print statement in it. But normally, several copy constructors are defined by default. Copy constructors work recursively. If your class has other objects as members, they get copied recursively. So if your class has an array in it, do not think an array is a C-style pointer to data. An array is basically, it acts like an array. So if you copy an object that contains an array, it does not copy the pointer, it copies the whole array. Okay, so I define a hasInt that contains 5. I define another hasInt by using this one, so that's the copy constructor. Okay, the first line, hasInt, it prints set 5 because that was the constructor. This line calls the copy constructor, so it says copy 5. Now I call the print me on the original object, it says I have 5. I call print me on the other int, and it also says I have 5. Okay? Copy constructors are defined by default. The only reason I do it here is for printing it out. Every class has a destructor, also defined by default. The default destructor doesn't do anything. Well, it does the following. If your class contains objects, if your class contains data, then that data gets deallocated. That is not overly deep, but if your class contains other objects, they get destructed. And so if they have data, it gets freed. So normally a destructor does the expected thing. So normally if you have curly brackets and you define an int, or you define an array of 5 integers, after the closing curly brackets, they get deallocated, they don't exist anymore. So objects get deallocated. But with the destructor, you can do clever things. Suppose your object opens a file and in order to write to it, then you could, for instance, in your destructor, close the file. And so whenever the object goes out of scope, including because you do a go to out of your scope, if the object, for whatever reason, disappears, it calls automatically the destructor. And so if you close the file in your destructor, you nicely get, you don't have to think about closing your file. It gets done for you. This is really, really cool. This makes C++ so much cleaner than C. In C, if you your program has a complicated logic of when it leaves a block, there are multiple return statements or something, or there is even, God forbid, a go to, then you may miss closing your file or deallocating data. With destructors, you can completely automate this. Okay, destructors are called implicitly. You don't call them. I have a class sum object which my constructor says I am the constructor. My destructor says I am the destructor. Okay, now let's trace down this program. Print before the nested scope. See, curly brackets, nested scope. So it see out before the nested scope. Inside the nested scope, it creates an object. So it says calling the constructor. Then there is a statement that says inside the nested scope, you go outside the curly brackets. So because this object lives only between the curly brackets, it goes out of scope and it's destructed. So it says calling the destructor, but I never call the destructor. No, it gets called implicitly. So as soon as this object stops existing for whatever reason, the destructor is called. So if in this object you'd opened a file, then you could have closed it in the destructor and it would have done so automatically. And then you print after the nested scope. The point here is that the destructor is never explicitly called. It calls whenever the object stops existing. This is really cool. Yeah, we'll get into exceptions later. So throw means there's something really gone wrong with my program. I don't know what to do. I just tell it quit. Now it is possible to say quit and only quit a couple of levels. So you can do a throw, and then your programs can say try this, and if something goes wrong, it's called an exception. You can catch the exception. We'll see this in detail. Anyway, if you do throw your program and no one catches it, then your program completely exits. But you can catch it. Anyway, as soon as you do throw, this object goes out of scope or something. The destructor gets called, including if you generate exceptions. So exceptions are a clean way of indicating that something goes wrong with your program. And because they call destructors, it's a very clean way, and you can actually throw an exception and somewhere else in your program catch it and be able to resume your program, do some repair, and you don't have to worry about memory leaks, even if your program has this sort of semi-abnormal ending. Okay, I think that's mostly it for object-oriented programming. Oh, no, it's not. We're nowhere near it. The end. Headers, right. So if you've written anything non-trivial in C, you know how you write .h files that contain prototypes. That is slightly more complicated with objects. So you need to put you need to put a fairly good amount of your class definitions in your .h file. So in your .h file, of course, you need to say that there is a class something, but you also have to define all the methods that are defined in that class. So this is your header file, and then you have an implementation file where you write it like this. So if this was plain C, then you would have a prototype and you would have a function, double, whatever. In C++, the method is in a class. And when you define the function, you have to define what class it belongs to. So some do comes from something, and so you write something, : some do. The : means class, method, or even class data member. Okay? And quite strangely, data members have to go in the header file, even private ones. This is generally considered to be pretty ugly. I mean, it's private data, so why do you put it in the header file, which is kind of public? So, not sure why they couldn't come up with a cleaner design of that one. On the other hand, it's private, so the user knows that it exists, but they can't do anything with it anyway. Static class members. So far, the data members that I've shown you, if you make two objects, they both get a copy, they both get an instance of that data member. Suppose you want to have your class contain a count of how many objects have been created of this class. Then you can have a, whoops, that is a typo, that should say static int. Slide 6, let me make a note to myself. Slide 61, static int. So that should say static int object count, and then every time the constructor is called, it increases it by 1. So just saying static object count doesn't actually create the objects. Somewhere in your main program or so, you still need to say my class object count, and you can initialize it. Also, slightly strange syntax. Okay, so you've seen a couple of examples where you had objects, maybe objects of two different classes, you combined them. There are formal relations between classes. So if you have a class course and you have a class person, the course class will probably have a person, the instructor, and it may have an array of persons, the students. So it is pretty normal for an object to contain other objects. This is called the has-a relation. And so here are two different implementations of a class segment. So you want to have a line segment. So there's a starting point and an ending point. So suppose you already have the point class. You write your segment class, you store 2 points in it, and then you have a method get the endpoint, which returns the endpoint. Now, it's also possible, so in this case, you have an accessor function, get the endpoint, which accesses that thing. But you could also now change your mind and instead of implementing the segment as starting and endpoint, you implement it as a starting point and then a length and an angle to the ending point. And in that case, your function get the endpoint doesn't actually access data that is already there, it just does a computation. So the has a relation is sometimes literal, sometimes it's more metaphorical. Again, you see the virtues of using accessor functions. It means that you can change your mind about how something is designed and not have to change the calling program. Yeah, so I have the two different decisions about what to store in a segment class. So I can have a segment class, and either way, I'll have two constructors. So I have a constructor from 2 points, a constructor from a point, and 2 floats. And either way it works with either of the, or no matter how you implement it, I can still have both constructors. Okay, the has a relation. Yeah, this exercise is not terribly deep, but please take your point exercise and work on this for 5 minutes, because this will come back in the next topic. So I'll give you 5 minutes to work on this. Make a rectangle class. It's a axis-parallel rectangle. Make the constructor and implement the function, the float, sorry, the area method. The first bullet point only. From program then. add new reference. From somewhere else.
The code, the prime code.
You understand what's happening?
That's the Sure. How could this enable for the P2 or the distance? This will be read as other,
Yes.
and then other goes to your x and y. So for this x and y coordinate corresponds to this 4 and 5.
Correct.
Then how does this function take P1? Just P1 that means because this 0, 0 goes to here to find the x and y.
I think I put 1, 1 in P1.
Yes, right.
So if you do that, the distance should be 5 exactly. Does your program work?
Yeah, it works.
Okay.
Right. My question is, how could the P2 goes to here? But
Yes. So P1, so you ask P1's distance. So distance is evaluated where the point is P1. So distance thinks that x, y are the P1 x, y. So x is 1, y is 1, and then you do the distance to the other.
Okay.
So when you do P1's distance, then the function distance is evaluated in this object where x, y are for P1. Function distance thinks that x and y are sort of global to it, but they are contained in the object. So P1 is an object where x, y are both 1. And so distance thinks that x, y is 1 and 1, and then you give it another, you can get the x and the y of that.
And the other x and y comes from
That comes from P2.
Yeah, other, and the other is
Yeah, so
P2.
distance P2, so P2 that's copies to the other.
Okay.
That's easy. Yeah. So you just need to initialize the private variables.
I was trying to do the second portion.
Oh,
I think the first portion.
okay, so the first portion looks good. And then you try to write another, okay, yes.
Yeah, well, I'm not quite sure.
In fact, you can do it again with initializer lists.
With initializer list.
Yes.
Both points?
Oh, yes. So, okay,
Over here.
okay. First, do it this way. So, what is the width?
The width is,
You have 2 points.
yeah, need to subtract, right?
Yes.
That's the
Yeah,
top,
yeah.
top right. Dot. Oh, but then
With, so it's the top right, what?
uh, x.
Yeah.
Right. Minus BL. But which BL is it?
I'm sorry?
Which BL is it? Is it this one or is it this one?
Oh, that's a good one.
Is it going to compile or is it going to
Well, you initialize it that way anyway, but it's probably this one.
Okay. Okay. And then I guess that.
Yeah. If this works the way you expect it, see if you can do the whole thing with member initializer list.
Everything. I see.
Yeah.
Okay.
Okay, how you doing the second one? The first one says store the point, the width, and the height. Oh, so not store 2 points, store 1 point, and then width and height. So everyone got this far. So the first bullet point says store the bottom left and the height and the width explicitly, and then write a constructor which does the trivial thing. So I'm using a member initializer list here. And now we want, for instance, the area function, which is return height times width. That was easy, right? Okay. Rectangle R, let's see, P1 and 1 wide and 2 high. See out area. Boom. Okay. Okay, that is correct. Let's see, what was I going to point out? Yes. So the second bullet point says, can you write another constructor that takes 2 points, point bottom left and top right. So bottom left is obviously bottom left. Now I can write a constructor body that says height is bottom left, top right, y minus bottom left, y. I could do this, but I can in fact make it easier. So I can say height is top right, y minus bottom left, y, and width is top right, x minus bottom left, x. And again, I have an empty constructor. Let's see. Rectangle, let's do the same thing as P1, and it's 1, 1, and I want 2, 4. Oh, why not? Is that not allowed? X is private. Yes, it is, but oh, right. Ah. Okay, the rectangle cannot get at the points. Okay. Okay. No, it should have been 2, 3. Okay, so I made 2 different constructors, and I use member initializer lists in both cases. Let me make that slightly more readable. Okay, so you sort of see what's happening. Okay. Yeah. Okay, let's keep it at this. We are at about the 3-hour mark. So time for lunch. People that are new to this area, if you go out the door, you'll see a water tower. That's where the entrance to the Commons building is. The Commons building has a pretty nice cafe for, I don't know, $5, $6 sandwiches, $10 the daily hot plate. Friday, they probably have crab cakes, which are a little over 10. Anyway, it's a decent cafe, so it's 2 minutes walking that direction. And let's reconvene exactly an hour from now. If you want to keep working during lunch, you can read this and do the next exercise. And the next exercise is take your rectangle and make a square class that is based on the rectangle. Okay, that's what we're going to be doing after lunch. We went a little slower than I was expecting, but I hope doing all the exercises has been beneficial to you. So in the afternoon, we'll do inheritance, and then we go to arrays, vectors, strings IO are simple. Smart pointers, I definitely want to cover, and with a little luck, you can find time to do one of those. Okay, that's it. Break for the next hour exactly. We resume at 1:05. let's. Okay, so this has shown you a couple of aspects of dealing with classes. So you've seen about constructors, member initializer lists, functions that do various things with classes. Okay, inheritance. This is another level up in complexity of objects. So you have there may be cases where you have a class, say rectangle, and then you have a special case of a rectangle, namely a square. A general rectangle has a width and a height. A square has both of them to be the same. So is there a way to reuse code for the rectangle code in order to implement the square? In both cases, the area is computed the same way. It's height times width. It's just for a square, they are the same. Okay, so this is called inheritance. A square inherits from a rectangle, or it derives from, or square is a subclass of rectangle. Different terminologies. Okay, class general, so that's the base case. That's also called the base class, and then the other one is called the derived class. So a whole bunch of terminology, different ways of saying the same thing. Look at the keyword protected. So protected is sort of in between private and public. It means that it's private, except that special cases can also use it. So it's still not public. It's not that everyone can use it, but it's also not private. So protected. So my general class has a data member G, and it has a general method. Okay, now the syntax say that special is based on the general case if class special, public, general. You can also write private general, but that is really weird, and I've never seen that in real code. So public, general. So special inherits from general or is based on general. And so let's say we give the special class a special method. Okay, so because it inherits from general, everything that exists for general now also exists for special. So if I make a special object in my main program, then the special object has both the general method, because the special object is also the general one, and the special object has the special method. Okay? So the special has everything that is defined for the general, plus maybe some extra methods or data members. So the derived class special inherits methods and data from the base class. So the base and the derived and inheritance. Note that numbers and methods need to be protected and not private to be inheritable. So now if you create a special object, it has a constructor, so what happens? Well, first it calls the constructor on the general object, and then it does any extra actions. In fact, you need to, you can call the constructors explicitly. So your special class inherits from general, and now this is how you write the constructors. You say that your special class, and the constructor calls the constructor of the general case, and then maybe extra actions. So in this case, the general constructor had two parameters. The general constructor, sorry, the special constructor has only one parameter, and you do something. Okay, this is, I'm not sure if this example conveys it. Private, public, protected, you've seen this. Okay, take your rectangle class and write a class square that inherits from it. And then in your main program, make a square and compute the area of it. So because the rectangle already has an area, the square will automatically have the area function because it inherits it. The only trick here is in the constructor. Is that still the same copy as this morning?
Yeah. Awesome. Do you want her to remake the font?
Still long enough. I've got my notions in this, but
There might be some caffeine in it. I've had like 3 cups.
yeah. Yes. You can also do private, but that doesn't include read it. So just automatically write public. Control A. Control E. A. Beginning and end of the line. Then what cursor keys? Let's see. Okay. Okay, start writing your yes. Well, count square if you would.
Here I have this constructor and which is subclass, I mean inherit rectangle. As we discussed that the constructor of rectangle will be called and it has 2 inputs.
Correct. Rectangle. So use the constructor that has a height and a width. Right. So the rectangle is the point, width and height. Square is a point and the width.
So how does the rectangle class know which constructor I'm calling? It is automatically called. How does the rectangle class know that I'm going to use this particular constructor?
Well, it recognizes it. There's one constructor that takes 2 points, and the other one takes points, float. So it's kind of it's clear to the compiler which one is which. You can just determine that by analyzing the code.
So basically, this is exactly the thing. Okay.
you have modified.
So now write a class square. Inherits from, so you need to make sure that it inherits a square colon public rectangle. Take a look at the previous slide or so, that one.
Okay.
The special case colon, yeah. So the special case is the square. The general case is the rectangle. Go back to the end of the previous line.
Okay.
Yeah, one more backspace. Okay. So class square colon public rectangle. All there is to it, yes. Everything else you get for free. It works. So cool, right?
It does work, yeah.
Yes, yes, it is very cool. I'm mentioning this here in the presentation, but there's something called delegating constructors. So if you have one constructor and you can express the other one in terms of it, then you can use this colon notation.
Oh,
So
so similarly as a base, but not under the base. but
within
within
the class, yes. So just as an exercise for you, take your rectangle class and see if you can express the second constructor in terms of the first one with the colon notation. Okay. It's called delegating. Let's see if you think of that. Okay. You probably, yeah, okay. I don't need it here. But sure. You can remove those panels and put these two next to each other. This is a really tiny window. Okay. No, it's a constructor that takes a point and so you're trying to define the square from 2 points, but not every 2 points define the square. They have to be at 45 degrees from each other. So look at the rectangle from the point, width and height. And similarly, write a constructor for the square that is point and width. So a point and a float. Okay. So yes, so you need to take this one. Yeah, okay. You can fill it in later. So go to your square class. And now, okay, this is not, no, length and width. Yes, just length. Make sure you set float. Okay. So now what you need to look at is 1 or 2 slides back. If you have a derived class, then you need to do something with the constructor. Yeah. The special case derives from the general, and the special constructor calls the general constructor. Okay, I don't want to get stuck on this too long. So I've implemented my class rectangle, class square inherits from rectangle, and a square, which I create from a point bottom left, and a float okay, width, whatever. So a square with a bottom point and a width, that is the same as a rectangle with the bottom point, that width and the height equal to the width. So the rectangle takes the bottom left, and then it takes a width, and the height is the same as the width. The rest is zip. How about 3? And 3 squared is 9. Okay, do you see how beautiful this is? A square is a rectangle. Every function like area that is defined on a rectangle is also defined on a square. So down here, I defined a square, and then more Emacs power manipulations. How do I get 2 views on the same screen?
Control X2.
Control X2 gives you above them. Control X3 is next to each other. Okay, so in the main program, I defined a square based on a point and an extent of 3. And so the area clearly became 9. So a square is in every respect a rectangle, except that it gets constructed from only the width. But a square with a bottom left and a width is the same as a rectangle with bottom left, the width, and height equal to the width. So all of the magic here happens in the constructor. And that's it for inheritance. There is more that can be said about it, but I won't go too far. Right. Okay, so if you have a base class that has a certain function and you want to redefine that function in the derived class, then you need to declare it as virtual here, and then you say virtual override what was earlier. So you can make changes. Okay, this is not related to inheritance, but you can redefine arithmetic operators like plus and times on classes. You can even redefine square brackets and parentheses. So for instance, here is how do you multiply a point by a factor. So you do that by defining operator star. And so now you can take a point and say point P1 times 2. This is advanced stuff, but I thought I'd mention it. You can write really nice and clean code. More stuff. Multiple inheritance. If something is a special case of both this and that, then you can do multiple inheritance. There are certain dangers to this. It is sort of related to mix-ins in Ruby, in case you know that. So what you saw was a base class that has a bunch of methods and then a derived class. But maybe the variations can be so drastic that you basically don't put anything in your base class. So that's called a virtual base class. For instance, suppose you have a finite element package and you have a grid based on orthogonal, so you have a Cartesian grid, or you have a irregular grid. The two are completely different, but still you want to be able to define, say, the norm of a vector on that grid. In that case, you would define a base class and you would define virtual base functions. So you just say that any specialized grid needs to define the norm function. I don't even give the syntax here. And so then you write a Cartesian grid and you write a irregular grid, and they both inherit from grid. But the only thing that the grid class does is it says you have to define a norm function. The good point of that is, of course, that now you can write a main program and you use the norm function, and however you implement your grid, it will have a norm function. Anyway, virtual base classes, that's kind of higher lore. Friend classes, yeah, so with protected means that derived classes can get at the data of the other. Sometimes two classes are kind of friendly with each other without being in a derived relation. So you can indicate friend class. So that means that you tell it that another class is able to use the data directly. Don't abuse this. Okay, that's it for object-oriented programming. Cool? What? Yeah, I hope so. Okay, arrays in C++. So, yeah, you can still have static arrays. So int numbers is that. So two different syntaxes. Int numbers equals a initializer list, or int numbers initializer list. Both with static arrays and with what we will get in a minute. There is a new syntax for iterating over an array. So quite often, so in C, the only way you can iterate over an array is to say, okay, with the index from the first to the last. But if your iteration is basically a for all statement and you don't actually care about whether you go through it forward or backward and you don't need the index, then here is a simplified notation. So if your array is an array of floats, then you can say, for every float E in that array, do a statement. In fact, if you don't want to remember if your float is, if your array is float or double, then next new thing in C++, auto. If the compiler is able to derive what type it is, then you don't have to remember it, you just say auto. So with every element in the array, whatever the type it might be, I don't remember if it's float or double, long double, whatever. Okay, so let's see a quick example. Computing the maximum. I have a, oh, this is not an array, this is a vector. Kind of a preview of what you'll get in 1 minute. I have an array of numbers. This also works with the traditional notation. My max is numbers 0 for every v in numbers. If v is more than the max, then the max becomes the max. And you run this and it gives you the right output. Okay, so in this case, you would, computing the max, you're not interested in the index, you just want the value. So you say, okay, this is called a range-based for. So you just say for every element in this range. There is a subtlety about that. If you say float v in whatever, or auto v in numbers, it actually makes a temporary copy of the array element. So you cannot use this to scale the elements of the array. If you want to scale your whole array by a factor, then here comes the reference in. So for every v being a reference to something in the array, multiply v by 3. So what am I doing here in this code? I create an array that has in the zeros location 1. I scale the whole array by 3. I print out numbers 0 and I get 3. Okay, so range-based for usually makes a copy of the array element. But if you want to change the array, just use a reference. If your array consists of really complicated things and you want to save on copying, but you're not interested in changing it, use a constref. Okay, I already showed you the vector keyword. So you need to include vector and then using standard vector. And then you can say vector of whatever type. So that is, sometimes I will just say array, but I really mean vector. So it's like a type definition that is parameterized with the type. Vector of int something, vector of double something, vector of point something, vector of rectangle something. So whatever type you may have, whether that's in a basic type or a class, you can put it in there. If you make a vector and you don't tell it what size it is, you will get a vector of size 0. Why on earth would you use a vector of size 0? Well, vectors are dynamic, you can stretch them. But if you know in advance what the size is, you indicate it. Okay, even more. So vector of double x with a size of 5 and initialize the whole vector to 0.1. And then you can use angle brackets to assign or read elements from the array. There is another notation. Instead of using square brackets, you can use @. The @ is slower in usage, but it does bound checking. So it might be a good idea when you develop your code to use @ and then.
I have a question. My friend was explaining me this one day about the range checking. And he was saying that you can activate it or deactivate it at compile time. I'm not sure if that's right or not. I don't know.
No, I don't think you can. I think the language definition of @ is that it always checks. So you need to be more clever about it.
Okay. Is it possible to have the other one? Range
Let's see. What I would probably do is redefine the square brackets so that they use @. And then if my code goes into production, I remove the redefinition.
Okay. Okay. Cool. Wow.
Yeah, I don't think there is a compile time way of doing it. So let's see. So vectors are the new and improved arrays. In C, you don't really have arrays. Okay, you do have arrays, but they immediately decay to pointers if you look at them. So C arrays are basically memory addresses. Not entirely, but basically. So this is silly. Pointer arithmetic, you hardly ever need it. C++ vectors are basically as efficient, and they're safer, and they're easy to use. So in C++, never use malloc. There is something called new, which is sort of a malloc, except that you don't have to do the typecasting. So you are allowed to say double star array is, this is basically malloc n times the space of the double. But the keyword new is also basically not necessary. I know of one very far-fetched reason why you would use it. For you, basically no. Never malloc and basically never new. So arrays, always do them through vectors. Over a vector, you can also iterate and you get the same thing. If you do auto, my element in my vector, it makes a temporary copy. So if you want to scale, okay, so this illustrates, it's 1, 2, 3. You multiply everything by 2, but because you're not using the reference, you get copies of the vector elements, and so the copy gets multiplied by 2, and now if you output element number 2, it's still 3.3. Whereas if you use a reference, then you get a reference to the actual array element, and now you have the same initialization. You multiply the array by 2, and the final element has been multiplied by 2. Okay, ranging is a good thing. Let's see, did you actually master this? So create a vector x of a couple of float elements, just set a couple of random values. You can, for instance, use the curly bracket notation. Normalize the vector in L2 norm, and then compute the L2 norm of the result and make sure that it is 1. Okay, go.
I'm still caught up on what you just said a while ago about not using new, but then how do you allocate dynamic memory if you don't use new nor malloc?
Well, as soon as you know how much you need, then you go into a new scope and you declare a vector of that size.
Oh, okay.
And you can adjust the size of the vector, as you proceed into the program. The vector can be resized.
I see.
You don't have to
That too, but as soon as you know the size, you can just declare a vector.
Okay. It's not correct. I don't know how I computed it. It's not correct. So what I'm doing is I'm first computing the
Is there a square root missing somewhere?
square root. Maybe here.
Well, you have the sum, but the sum is not the L squared, L2 norm.
No, it's
But
just
you're,
sum of those squares, right? So this is the sum of those squares. But then what do I need to do in order to know what do I divide for? So that
well, if the sum of squares is 1, then the square root of the sum of squares is also 1. Okay, I see how you could confuse it. Anyway, the L2 norm is the square root of the sum of squares.
oh, I see. The square root of the sum of squares. Okay.
So it's a multi-dimensional Euclidean distance. Yeah, it's, what do you call it, denominator? That's usually used for fractions, but okay. Why do you call it denominator? Why not norm?
How that worked.
Okay. Let's see, go in the code. Constant ref, sure, why not?
Oh yeah. When you mentioned that, so what is the threshold? Where should you use the constant ref for by value?
Just single numbers. I doubt that there is a difference. The compiler is probably clever enough to completely.
So in here it's just a waste.
Yes.
I see. So if you have like a class or something, then it's better to use the constant ref.
Yes. Yes.
Okay.
Yeah.
Okay.
Although if you put everything in one main program, then maybe the compiler can do interprocedural analysis. If it can see what your class consists of, then it might be able to compute the offsets explicitly and just substitute it. But if your array consists of objects that contain a pointer to something, and you don't know what's hanging on the other side of the pointer. Okay. Compilers are clever these days. You work for Intel.
I have no idea what compiler is though. I use the Intel
compiler is very clever. All the code optimizations that people used to learn, as in this is how you can make your code. If it's that obvious to you, it's been obvious to the compiler writer, and they've automated it.
Oh wow.
Yes. Okay. Okay, so C and C++ are zero-based index. So instead of 1, 2, 3, I would do 0, 1, 2, but I wouldn't do it that way. So the alpha, use another for loop to compute that. So here your code uses the fact that you know that it's length 3. So that for loop is good. But the alpha, I would compute with another loop. It's more elegant. Okay, it's already complaining here. Who is complaining? Hmm. What's about that green thing? You always need to look at your very first element. Vector was not declared. Okay, so take a look at my source. You need to have hash include vector and use extended vector.
Cool.
Is it compiling?
Yes. Okay.
Okay. What happens when you run it? 229, okay.
Is it correct that it's supposed to? I think it's not the number you have three.
I don't know. Show me the source. So scroll down a little and see the whole domain. Okay. The first rectangle has side 1 and 2.
Mm-hmm.
So that's an area of 2. The other one is, the other is from 1, 1 to 2,3. So that's 1 wide and 2 high. So that's also correct. So it goes from point P1, which is 1, 1 to 2, 3.
So area is 2.
Yeah, the area is 2, so that was correct.
How about this? We start from the 1.1 and we go to the 1. So you go 1 to the right. You go
2, yes. So the first rectangle definition uses this constructor, which is a point, a height, and a width.
Mm-hmm.
This constructor uses 2 points. You have that here.
Mm-hmm.
So it uses a point, and then it uses the curly bracket notation as this is another point.
Mm-hmm. So we use 2 different definitions for
Correct. You use 2 different constructors. Yes. Yeah, it's. I admit it looks a little confusing that both cases it looks like a point and 2 numbers, but it's not. It's a point. The second one is a point and a point.
Okay.
So your alpha is going to be the sum of squares.
Yes.
The sum of squares of what? Of vector elements. So you don't want to have alpha. So read this as for every element in the vector alpha is. So backslash over that alpha, put a letter E there. Okay, now it says for every element E. Okay. Okay, I think everyone has the basics of this. Okay. is the ranges? You've seen the initializer syntax. I should move these slides forward a little. The syntax for initializing a whole array with identical value. Yeah, so vectors are objects, unlike C dynamic arrays, which are basically memory addresses. If you copy a vector by using an equal sign for copy, it actually copies the whole content. So unlike C arrays, which don't behave like an object at all, if you copy an integer, you copy an integer. If you copy an array, you copy an array. So C++ is a much more orthogonal language. So what is a vector? It's a class. Somehow the class is parameterized with the type, but it's a class, so there are methods defined. You've already seen the add method. There is a bunch more. The most common one is size. So if you have a vector, you don't have to remember what the size is. You can just ask array.size. There's a whole bunch of other methods: front, back, insert, delete. Since the point was raised, indexing. So you can use square brackets. So if you have a vector of length 5 and you ask for element number 5, that is strictly speaking illegal because 4 is the highest index in a zero-based indexing scheme. But this will probably actually work as long as your array stays under 2048 elements or something like that. It'll probably work as long as it fits on a small page or something. But it's much safer to use the add notation. That actually does bound checking. Vectors are dynamic. Unlike C arrays, which you allocate, and if you decide, oops, I needed one element more, then you need to allocate a larger one and copy the old one over. C++ basically does the same thing, but it gives you a nice syntax for it. So I make an array of length 5, and it's completely indexed to the value 2. Now I push back, that means push onto the back of the array the value 35, and now I output what is the size of the array. It turns out to be 6, and what is the last element? It turns out to be 35. So there's pushback, which makes the array one longer at the end. Maybe there's a push front. There are too many of these functions. I always have to open the CPP reference webpage. There's pop back, so that means remove the one from the end. There's insert, where you can insert elements at an arbitrary place. There's erase, where you erase an element and you compress the array a little. All this flexibility comes at a price. We'll go into that. Multi-dimensional vectors, it's not quite as elegant as multi-dimensional arrays in C. On the other hand, those are ugly anyway. So you can have a vector of floats. That is one way. I'll show you in 2 or 3 slides a better solution. Something about the dynamic behavior. So if you create a vector and you don't indicate the size, you get size 0, and you can create your array by pushing onto the back. So let's see what happens if you do a couple of these things. So create a 0 size vector called flex and push stuff onto the back. Or what happens if you give it a static length and then you use the add notation to fill it in. Or what happens if you create it statically and you use the square brackets notation. Or what happens if you use dynamic allocation and you use static. So I coded it out. I ran the whole caboodle. So obviously pushing elements to the back, flexibility comes at a price. It's 2.5 seconds. I think, I don't know. I don't remember how many elements I used here. So 2.5 seconds as opposed to a minimum of 0.3, so that's 8 times slower. Static allocating, but using the add function, which has the bound checking, takes about 4 times the minimum. What was static? That was creating the size once and then using square brackets. That is the fastest. And mallocing, followed by using static, is for some strange reason that I don't understand slightly. Oh, maybe I didn't allocate it 64-byte aligned or something. Yeah, maybe. So, anyway, so if you know the size, just allocate it that way, and any sort of safeguards and flexibility comes with a certain price. Yeah, we're running later than I was expecting, so I'm going to skip a couple of exercises. Take a vector of integers and construct 2 vectors where one has the odds and the evens. So you can use that by writing a loop over the original vector, and then you push back on the one or the other. Vectors are objects, are just data types. So you can have a function that returns a vector, no problem. You can have vectors as function arguments, but note that passing by value will copy the thing that you pass in. And in the case of a C++ vector, that is actually copying the whole thing. So not just copying the address as in C, but actually copying the vector. So in that case, what am I doing here? Yeah, okay, this illustrates that it's passed by value. So what you actually want to do is pass by reference. That makes it much cheaper to pass a vector into a function. I thought I mentioned constref here somewhere. Okay. There's a question on chat. I don't know what he means by normalized. I'll ignore that one. It should work. Anyway, so right, so if you have a vector inside the class and you don't know how much it needs to, how big it needs to be, then obviously you cannot create the vector. So what you would do is you create a 0-length vector inside the class, and then in your constructor you assign a vector to it. And this you can optimize a little by using the member initializer list. I'll make a note of that to myself, slide 108. Okay, so you can create a vector of vectors and write a matrix class that way. It's probably a better idea to cut down on indexing and keep your data contiguous by making a single vector. In fact, this is the same as you do in C. C has really crappy support for multidimensional vectors. So if you allocate them dynamically, you just allocate them linearly, and then you write a translation from your ij index to a linear index. So in your matrix class, you can create a linear array of elements that is enough for your matrix, and then you write a function of I and J that does the indexing. A little bit about strings. So include string using standard string. In other words, string all of a sudden exists. A string acts like an array of characters, and not a stupid C array, but a beautiful, it's a vector of characters, I should say. A string acts like, Susan, please edit away the last 30 seconds. A string in C++ acts like a vector of characters. So you have string operations. You can initialize a string in the expected ways, but you can concatenate strings because the plus operator has been defined on the string class. And a string is like a vector in the sense that a whole bunch of the methods that exist for vectors like size now exist for strings. So you don't have to rely on a null terminator, but you can query a string. What is your size? And there are other methods defined, so insert, empty, erase, pushback. Most of the things that exist for vectors now exist for strings. And then there are a couple of methods that are particular to this derived class, and that those are like find. Okay, no exercises about strings. So with printf, you have pretty fine-grained control over your output. So far, you've been using cout, and it may have seemed a little crude. So let me show you how cout can be refined a little. Normally, cout, you print a number, and it takes whatever is the amount of space you need for it. If you want to get those numbers nicely aligned, then you can do the following. So take a look at your output. It uses a width of 6 characters for displaying your integers, and as soon as you go over 6 characters, of course, it spills out on the right. Unlike Fortran, which then would start using stars. Okay, what am I doing here? There is something missing up here. What am I doing here? I cout number I, but right before I specify I do set width to 6. Take a look at this, set width of 6, and then I print 1, 2, 3. What happens here? I get 6 spaces, 5 spaces, and a 1, and then 2, 3. So you see that the set width only applies to the immediately following number, which is why I have the set width inside the loop and not outside. So some of these modifiers are global, some of them hold only once. Okay, this is the line that I was missing. You need to include yet another header, namely IO manipulation, and then you use using standard set width. Okay, so you saw an example of printing every number 6 wide, and by default it uses the space character to pad. If you set another set fill, uses a different character for padding. Here is where you see my cleverness suddenly showing up. I told you about the write 18 in LaTeX. So these snippets come out of working programs, and to indicate what needs to be clipped, I put some markers in it, and something went wrong here. Slide 121 needs to be updated.
Yeah, I was wondering about that earlier.
Yeah, so before I format the book, I go through my source files, and based on the special formatted comments, I clip out these bits to name files, and they get included and the program gets run.
So fancy.
Okay, so set width sets the width. Set fill sets the fill character. You can use set width and use left alignment. Where did I do that? Oh, see out, and then it said left, and then set fill. There's a whole bunch of these modifiers, and together they are quite enough. Okay, again, homework exercise. I use set base 16, and I set the fill character to space. And now I print out the numbers from 0 to 255, and I get that table, and it looks pretty nice, except for the top line. So if you want to test your understanding, see if you can figure out how to let it display like this. So that's a homework exercise. Okay, Alex is asking about null terminators. Alex, there are no null terminators.
So you just put strings. Where's the string library?
Yeah. Okay, fixed point applies to the precision behind the point. So here I set a precision of 4 positions after the decimal point, and you see what's happening. Yes, if you want to do an exercise, if you have numbers under 10,000 or something, see how you can format them like this. Cute exercise. Scientific notation also works. So you get the usual output. Okay, this is a little deeper. In every program so far, you've had the include IO stream, which is for terminal input output. There is a whole bunch more. There is the F stream for file input output, and there is the S stream where you output to a string. Actually, string. So if you include F stream and then you using standard OF, which is output to file, then you can have an OF stream file out, which is now a stream that does not go to your terminal, but it goes to a file. So you can file open, no ugly file handles as in C. And now you can use the same angle notation to write things to a file. And then file close. Okay, there was a question earlier in chat about the angle brackets. So the angle brackets are not magic. They are actually an infix operator. And so I don't know if you might by mistake did it, but if you write a cout statement and you try to output an object, you get, I don't know, maybe the hex value of its address or something. I don't remember what happens, but it doesn't work. Cout only works on elementary data types. But you can actually redefine the less. What is less? What is angle? What on the left side it's a stream, and on the right side it is something that goes into the stream. So, and the result is another stream, so that you can put another less after it. Okay, so this is what's happening here. If you have a class container, then you can define the operator less, the operator angle. It takes a stream and a container, and it gives you another stream. Okay, I'm not showing the output of this, but you can sort of imagine what would happen. So now all of a sudden your classes can be output. You have to do this for every class, but it's pretty cool. So, and this is way better than what printf can do. Okay, we were supposed to run till 3. Let's do smart pointers, and then after that, well, maybe a little about lambdas, which I think are fairly nifty. Can you answer this, the last question?
Yeah, I was just looking for the slide that had the vector vectors.
Yes,
Vector.
there are no real multidimensional arrays. If you want to do multidimensional arrays, Fortran is by far cleaner. Okay, pointers. So let's again say something about pointers and references. Modern languages like C++ and Fortran have an actual clean concept of reference and pointer. The reference, or in Fortran, pointer, acts like an alias to the original object. C and C++ also have a very basic pointer concept, which is the address of the object. So that is very different from a reference. A reference is an alias. Two names reference the same object. A pointer is an indirection. If you are writing C++, you should not use the basic pointer concept. But of course, if you write C, you are pretty much forced to understand it. So you've already seen references. The reference makes the function parameter a synonym of the argument. Here we have the constref thing. So if you have a class that contains something big and you want to pass it to a function, then the whole thing would be copied. So you would pass it instead with a reference in the right column. Instead of passing it by value, pass it by reference. And if you want to protect it from being changed, use a constref. Okay. So that's references. Sometimes you actually, so in C++, you can get away without using pointers for quite a while. You can do a whole lot of things with references. But sometimes you actually need a pointer. For instance, if you have a linked list, a node has an info and it has a pointer to the next node. You cannot do this with just plain inclusion because you would get an infinite object. So you actually need a pointer. There's no way you can do this with inclusion or references. Okay, so now C++ has two concepts, and I don't think this lecture is quite finished. There is the shared pointer, where there may be two people pointing at the same object. And there is the unique pointer, where you know that there will be only one person pointing at an object. So a single linked list you can do with unique pointers. A double linked list, you probably want shared pointers because this one is pointed by the node before it and node after it. So I'm showing here only the shared pointer, which is the easiest one to use, but it has a little bit of overhead. But start by writing shared pointers. They are much nicer than C pointers. Okay, so how do you make a shared pointer? You make an object and you get a pointer to it. So you say the shared pointer to an object, X, is make shared object, and then you give it the constructor arguments. That's a whole lot of typing. So since you know what's on the right side of the equal sign, you know what the type is, you can get away with putting auto on the left. So you would say auto X is make a shared pointer to an object, and then you tell it how to make the object. So unlike C, where you have the object, and then you say, okay, give me the address. Here you have to do the 2 in 1. So you immediately get the reference to an object that you're creating, but the two go in one. So it's the allocation and pointer creation in one. Yeah, okay, so this is the only case that I know where the keyword new can be used. Namely, if you have if you want to point to a rectangle, but you want to create a square. So if this is a derived type of that, then you can spell it out like this. That's the only legitimate case that I know where new is needed. Otherwise, please don't do dynamic allocation explicitly. And after you create a shared pointer, it acts like an ordinary, it's used like a C pointer, so the arrow notation works. Dereference and take a member. So a simple example, I have a class that contains a double, has X, I created from double. I have a function that references the value. Okay, how do I use that in the main program? I say X is make a shared pointer to a has X that contains 5. So that calls the constructor on has X with 5. But instead of returning me the object, it gives me the pointer to the object. So X is now a pointer to an object I've created. And so I can do see out the value of X. Or I can say X's value becomes 6. Note that value was a reference, so this alters the object. And now if I see out X's value, I get 6. So take a look at the right-hand side. Initially it was created with 5. I changed it to 6. Okay, so pointer notation after the make shared is the same as in C. If you absolutely need to get hold of the underlying pointer, then there is the function get. So if you have a shared pointer, you call get on it, it gives you the classic C pointer. So X arrow Y is the same as X get, and that arrow Y is, which is the same as X get, dereference, and then dot Y. So if you happen to have code that expects a C-style pointer and you work with smart pointers, then you can convert between the two with the get functions. So the old style ampersand doesn't work here. You cannot take the address and turn it into a shared pointer because shared pointers are clever. They do automatic deallocation for you. And so this code will give an error in the end that you try to deallocate twice. What happens with deallocation? Well, pointers have automatic memory management. So vectors have obey a scope. So if you create a vector, it dynamically allocates something, but a vector otherwise lives between curly brackets. And so if you go outside the curly brackets, the vector disappears and the dynamic memory disappears. If you have objects, and a vector is an object, if it goes out of scope, the destructor is called. This in C++ is called RAII. Resource allocation is initialization, which is an inscrutable name. It could have been improved. So dynamic allocation does not obey scope. You create something and then you assign it to a pointer, but the pointer may go out of scope. The allocated thing does not go out of scope. So this is where memory leaks come from in C code. Now the fun part about smart pointers is that if the pointer goes out of scope, it checks if maybe the object needs to be deallocated. So if it's a unique pointer, then it knows that there's only this pointer pointing at it. If the unique pointer goes out of scope, the object is deallocated. With shared pointers, it keeps a count of how many people are pointing to the dynamically created object. And once they all disappear, the object is deallocated. This is not memory, this is not garbage collection, which basically is a sweep up after you've had a whole bunch of memory leaks. This is reference counting. Okay, let me show how this happens. let's make a class where the constructor and the destructor do a print out statement. And now let's create a pointer to that class. So let's see. I see out set pointer 1. Take a look at the output in the right column. Set pointer 1. I do thing pointer 1 is make shared to thing. So that it makes a shared. It makes a thing and it gives you a shared pointer to it. So by making the thing, it calls the constructor. You see the message. Okay, now I take my pointer and I overwrite it with null pointer. So in C, this would have been a memory leak. My dynamic memory is still there. It's just that my pointer has been overwritten. So C++ actually detects that the only reference to this dynamic object has gone away because it's been overwritten. And so as soon as I overwrite the pointer, it calls the destructor. So the dynamic object disappears. Beautiful. Okay, let's take a slightly more sophisticated example. Thing pointer 2 is make shared to thing. And now I create thing pointer 3, which is a copy of thing pointer 2. So now pointer 2 and pointer 3 are both pointing to the same thing. I've done a pointer copy, not an object copy, a pointer copy. So pointer 2 and 3 point to the same thing. I overwrite pointer 2 with null pointer. So that one's gone away, but pointer 3 is still pointing to the object. And only when I overwrite pointer 3 does the object go away. So let's see, do you see that happening? I set my pointer 2, it calls the constructor. Pointer 3 is set by copy, so no constructor, it just becomes another pointer to the object. When I overwrite pointer 2, nothing further happens, but when I overwrite pointer 3, the last reference to my object is gone and the structure is called. Okay? Dynamic deallocation completely for free. What is the there's a section here about linked lists. So by the way, so this is using classical C pointers, and you see that the keyword this appears 1, 2, 3, 4 times. The first 2 can actually go, but the return this and other tail is this. You really need that pointer to me. Yeah. Okay, I'll just mention it. You'll run into it probably a year from now. So if you have a shared pointer and you call a method on that object, inside the method, the object is accessible as this, but this is not a shared pointer. This is a classic pointer. So can you convert it back to a shared pointer? And that's where this absolute black magic happens. So if you declare your class as public, enable shared from this node, don't ask me what it does, but then you can say this shared from this, and that becomes a shared pointer from to this. Just store this away. You'll probably run into it a year from now or something when you write something very sophisticated. Linked lists. Yeah, so unfortunately this is completely exercises. So I'll let you do this at home. So a linked list is a unique pointer to the head node, and a node is a unique pointer to the next. And now you want to have if you have, so we're doing the usual algorithms 101 or CS 102 class. So you have a linked list. How do you compute the length? Well, you do that recursively. If the head of the list is a null pointer, then it's 0. Otherwise, it's the recursive length of the head node. And this is length of a node, and this is the length of the list. But so this works with any sort of pointer, including smart pointers. It still uses the arrow notation. Let me point out something. So this is very sophisticated C++. With shared pointers, you can have any number of people pointing at an object, but sometimes conceptually it makes sense to think, is a pointer actually ownership, or is it just pointing in order to look at something? So if you have a linked list, the link to the next node, that is ownership. But once the list exists and I go down it just to count how many elements, I need a pointer to point at the elements, but that's not ownership. That is just looking at something. So the iterative computation of a list length goes like this. So I'm using unique pointers, but the current node that I just look at, I do that with a classical pointer. So I take my head node, which is a unique pointer. I call get on it to get the classical pointer. And as long as that classical pointer is not the null pointer, I count 1 and I go to the next. So this is kind of state-of-the-art C++. If you do shared pointers, then that's the easiest to program. But if you use unique pointers, then you sometimes need what they call bare pointers. Yeah, you can go through these exercises and implement a linked list yourself. It's a cute exercise. It's fairly easy with shared pointers. With unique pointers, you need to think a little harder. There is a null pointer, which is not the same as null. It's an actual object. There are reasons for using it. Namespaces. So namespaces. If you do include vector, if you only write include vector, then you can say standard vector, because vector is in standard. Some of you have been writing using namespace standard. So once you include vector and then you say, okay, using namespace, meaning if I use a name like vector, then let's just assume that it comes out of namespace standard. There are certain disadvantages to that, because using namespace standard defines hundreds of routines for you, including ones that you may have wanted to define yourself, so you get really bizarre bugs. So it's more prudent to do include vector and then say, okay, if I say vector, then it's the standard vector. Why not using namespace standard? Yeah, so my poor students wrote swap ij, and they forgot to define swap, or they made a typo. This code actually compiles, because swap comes out of namespace standard. Whereas if you did it this way, then swap would be undefined. Swap is defined in IO stream. Okay, so using namespace standard, use at your own peril. Even if you use using namespace, never put using statements in a header file, because the using statement implicitly defines a whole bunch of routines. So now the header file is something that you give to the person using your code, and you don't want to define a whole bunch of things for them and confuse them, even if you keep tabs on what you're doing. So using should never, never, never go into a header file, only in implementation files. You can make your own namespace by writing namespace something, and then you have to qualify your object. So you can no longer say an object, my object. You have to say it comes from my namespace. So this is great if you write a finite element code and you want to have a vector class and still be able to use the standard vector. So in C, this would just give a complete name overload. Templates. So you've already seen templates in action with the angle brackets in vector of int. So vector is a class, but it's parameterized with the type of what is it a vector of. So the keyword template and the keyword type name. So you say a template, and let's make the type name variable. So you give a name to that. This is how it looks like. A template where the type name is t, and now I have a function of t where whatever t is. Right, so normally you'd say function f of int, function f of double, but you have to write them separately. So if the function f does basically the same with an int as what it did with a double, you can make it templated. And now you write your main program. The compiler says, oh, f is applied to an int, so let's compile it for integers. And oh, f is used on doubles, so let's also compile it for double. But your code will behave as if you define your function twice, once for int and once for double. Cute exercise, machine precision. Who here has ever thought about the computer arithmetic? Real numbers in the computer are not real numbers. They are float and double. Which is something entirely different. How many bits in a float?
4? No.
Float is 32. Double is 64. Okay. How are the 32 bits allocated? 1 is probably for the sign. I can never remember. 22 or 23 for the mantissa, and then the rest for the exponent. So that is what is left. 24 minus, so that's 8 bits for the exponent, which means that the exponent can run from plus to minus 256. Sounds reasonable. So you have 22 bits or something for the mantissa. How much is 2 to the 22? 4 million. How did I do that? What are the powers of 2? 2 to the 1 is 2. 4, 8, 16, 32, 64, 128, 256, 512, 1024. 2 to the 10 is 10 to the 3, basically. Okay? 2 to the 10 is 10 to the 3. So 2 to the 22 is 10 and 10, and then multiply by 4. So it's 4 million. Okay. Integers. How many bits? 32. 1 goes for the sign, so you have 31 bits left. How much is 2 to the 31?
Like 4 billion?
2 billion. Because
it's half, yeah, 2 billion.
Yeah. 2.19, I think. 2.14, yeah. Anyway, yeah, so floating point number has 22 bits or something, so that's 4 million. So because floating point numbers are normalized, so that they start with a 1. That means that 6 positions or so after the decimal point is the last one that you could have. And if you have a number 1 plus 10 to the minus 7, it doesn't fit in your mantissa anymore. So 1 plus 10 to the minus 7 is 1. Okay, so that is machine epsilon. What is the smallest number that I can add to 1 so that it gives me more than 1? Okay, with this introduction, now write a templated function epsilon, so that if you ask the epsilon of a float, it will tell you, it precisely falls off the edge of the slide. It should say 10 to the minus 6 or something. And for double, it's about 10 to the minus 15. Okay, remember those numbers. Single precision, 10 to the minus 6, 7. Double precision, 10 to the minus 15, 16, thereabouts. Okay, so if you do an arithmetic calculation in double precision, and it's a couple of computations, and you see that you have a relative accuracy 10 to the minus 13, 14, you think, I'm happy. It's 10 to the minus 3, get lost. Okay, so this is an exercise you can do about templating. Right, so it is as if the standard template library contains class vector, is templated, where the function at gives you a parameterized type T, size just works. So this, you can imagine that the C standard library contains this definition of a vector. So function at returns you a type name, whatever. Okay, that's templating. You can do more bizarre things with templating, but that's probably not a good idea. Exceptions. Yeah, so if your code has an oopsie, you can say throw something, and you can throw any sort of thing. So you can, okay, we'll get to that. So throw means throw an exception, as in throw up your hands and say, I can't continue. So now you can, if you have a piece of your code that you think may go wrong, you put a try catch block on around it. So you say, try this, and if it throws something, catch it, otherwise just continue. So as on the previous slide, you throw an integer, so you say catch an integer, but you don't have to throw an integer. You can throw, my favorite is that I throw dynamically created strings so that I can report back what the circumstances are where something went wrong. But you can create your own classes and error classes and put whatever information in it, and then you throw a error object, and then you try your code and you say, okay, catch an error object, and then you can analyze what the error was. If your code can throw multiple things, you can say, okay, if I catch an integer, then I handle it like this. If I throw a string, I catch it and handle it like that. And there is a default case. So the ... doesn't mean there is something omitted here. ... is literally. So if you have a catch with paren ... paren, then that catches any previously uncaught exceptions. Now you can put a try around the constructor of a function, try catch block.
You do that just to check for available memory, or
no, if you have a derived class, then it's kind of inside the constructor. You can have a try catch block, but the stuff that comes from calling the base constructor,
yeah.
This is how you put a block around that. because that exception gets thrown before you get to the derived constructor. There is a bunch of predefined exceptions like bad allocation, bad exception. So they are generated somewhat very deep. So it's usually a good idea to have a default catch, so that you catch those things. You can rethrow an exception. Exceptions are kind of cool because if your code throws exceptions and you want to be able to catch them in order to do some repair and continue operating, then exceptions become part of your normal workflow, and so you may want to prevent memory leaks. So this is an illustration that if you throw a exception that makes an object go out of scope, the destructor is called. So again, even exceptions don't cause memory leaks in C++. Iterators. So before C++ 11, this range-based for didn't exist. It's new in 11 or 14, and it is very nice. Before this, you had to spell it out laboriously. So a for loop, an iterating for loop, had to be written like this. Standard iterator it is vector begin. As long as it is not vector end, then increment it. And so it would then range over the vector. It wouldn't even be an element of the vector. It would be a classical pointer to the vector. So you needed to deref it. This is just ugly compared to this, right? But the iterator concept still is alive under the covers. So what does iterator depend on? It depends on a begin function, an end function, a termination test, and an increment. Oh, and a deref. So now you can take an object, you can take an arbitrary object, and as long as it has a begin, an end, a test, and an increment, and a deref, you can treat the object like you can iterate over it. So let's make a class called a bag that models a set of integers, and you want to enumerate them. So I actually use this in my own research code. I want to have a class that models a set of integers. Okay, well, if it's a continuous set, then you say, okay, everything from 100 to 200. But now if I delete the element 150 out of it, then it's 2 consecutive ranges. And now if I add elements to it, so I have a very complicated structure, but I still want to iterate over these elements. And so I write my own iterators over this complicated class object. So I have my bag, I call it digits, and it contains integers 0 through 9. And I illustrate here that I can have a for loop that goes over the digits. So this is not a vector. Digits is a bag, and a bag is a class. So there is nothing explicitly stored in it. There is no vector or anything stored in it, but I can still iterate over this. So how do I do this? Well, there needs to be a iteratable method begin and end. Okay, so how do you iterate over an object? You basically need to remember where you are, and then in every next state, every time you increment it, your pointer of where am I gets updated by 1. So I need privately something to remember where I am. Okay, so I write my begin function. So I set the seek parameter to the first element in the bag, and then return star this. Okay, this is sort of magic, but it means that you return a copy of yourself with the current state, meaning with the seek initialized. The end parameter is in this case just yourself. Okay, so it said while the iterator is not the end. So now I have the iterator is another copy of a bag, but with the seek parameter, and the end is just the thing itself. So the not equal test is if my seek is not the last of the test. So this is the termination test. I need to have an increment, which is increase the seek. I need to have a dereferencing. So if I have my current state of the object, what am I actually holding? That's seek. I'm racing over this. So
Are all of these functions inside the class bag? Or?
yes, yes,
I see.
correct. Right, because you have to be able to
Right. You have to be able to.
you have to be able to call the begin and the end function on your iteratable object. Okay, if you think you understand this, make another prime number generator. So make an iteratable object that is a prime number generator. I don't know, it's about 10 lines of code. But it'll probably take you more than 10 minutes. It's a lot of copying back and forth from the code that I had above. Anyway, yeah, so not every code will use this, but I've personally run into a case where I really want to iterate over an object that does not explicitly have a vector or something stored. We've seen this auto stuff. If the compiler can figure out what the type of something is, then just write auto and why would you have to spell it out? A vector of shared pointers of class is new vector of shared pointer of class. It's twice the same. The compiler can figure it out. Look at the right side, you know what it produces. So just put an auto on the left side. As you have seen in some of the C++ 17 can even, if you have a function and it's clear what the return type is, you can put auto there. Auto does not take into account references, so you find yourself writing auto ampersand quite a bit. Likewise, if you say auto something, then it becomes a copy of the right type, but not a reference. So if you want to auto reference get data is stuff. Yeah, and you can have const auto ref. Iterators, you've seen this. So this is just for good measure. Okay. Let me just do something with lambdas, and then we'll probably call it a day. So this really needs to be a day and a half training, probably, if we want to do all the exercises. Lambdas. So lambdas are functions, but they are functions that don't have a name. So it's like a function pointer. Yeah, they're probably a lot of function pointers, but they're more dynamic than that. Okay, they have a new syntax. Square brackets to indicate the capture. Parentheses for the input parameters, an arrow, and then the return type, and then the definition. So as an example, square brackets with nothing in it. So this it indicates to the compiler we are defining a lambda expression. So a function that takes an x and a y and gives you a float as follows by returning the x plus y, and you apply it to this, and I don't give the output, but I'm sure you can imagine that this expression prints out 3.8. Okay, this is entirely pointless. But you can actually take this function, this lambda expression, and save it in a variable. So summing becomes this, and then you can apply this name to some output, and it gives the same output. Okay, I've very quickly glossed over this. Why does it say auto? Well, there is something bizarre going on. Every time you write a lambda, it makes a unique class with only one object, namely that. And so you can actually not write down what the type of a lambda expression is, because every lambda expression has a unique type, which is dynamically generated, which is why you need that auto.
So you couldn't just say after this something equals to, and then another lambda, or can you?
Yes, something is no, the next time you'd have to say
Or some other variable.
if you now try to assign to summing another lambda expression, it will say incompatible types or something.
Okay.
Is what I'm guessing. Okay, I didn't say anything about the capture yet. That's what goes into the square brackets. So it's a function with certain inputs. But what if you wanted to define that function dynamically depending on the current context? Then you can use the capture. So suppose you want to have a function that only gives you the third power of its input. In C and in C++, you have the power function. It's part of the math header. So power of x to the 5 gives you x to the 5. But suppose you want to make a new function that only gives you fifth power. Then you say power function is 5 float x arrow float, return power. So it captures the current version of exponent, and it gives you a function where that thing is fixed. I should really make an example of this. There's more trickery involved with lambdas. So because they are of a unique type, you'll have a hard time storing them in a class object. So that's where the next header file comes in, functional, and using standard function. And so you can say my class selected ints. So what am I going to do here? I have a class that contains a bag of integers, and I want to put only certain integers in it. But I want to make the selector function dynamic. So the selected ints has a storage and it has a selector function. So it's a function of an int that gives a bool result. And so how do I create a selected integers? Well, I give it a function and it puts that in the selector thingamy. And now if I add an integer to this selected ints things, then it says, oh, only if the selector is true, then push it onto the bag. I hope you can sort of see what I'm doing here. So I want to say even numbers is a selected ints, and I give it the test function is something even. Okay, so suppose I have a number threshold, then I now make a selected ints greater than threshold. And so it's a function of one parameter, I, and it is true if I is over the threshold. So now I loop and I try to add all these integers to the greater than object. and et cetera, et cetera. So depending on the threshold, which could, for instance, be a number that is read in by the user from the terminal. So it's very dynamic. So the selector function is dynamically determined, not a function of two parameters. It's a function of one parameter with context information that is dynamically incorporated in it. And so I can do this. I think even would have been a better example next time that I teach this. Okay, that's it for today. If you want to do homework, suppose you don't have a square root function in your hardware. Can you compute a square root? Of course you can. That's you use Newton's method for that. Where my coffee go to? Did I finish it? My throat is killing me. If you don't have a root function, then you say, okay, well, the square root of y is the 0 of x squared minus y. So as long as you can do squaring and minusing, you can compute a Newton you can do a Newton iteration and compute the square root. So yes, so you need two functions of x, namely f of x, where y is part of the context, and f prime of x, where y is part of the context. So let's see. You write a class value finder, which contains your Newton iteration. You give it two functions, f and f prime, the tolerance, and then you use it as this is an exercise, so there are a couple missing bits, so that you can use it as a Newton root. Find number. So you can test yourself to see if, okay, casts are boring. Okay, so in C++, if you have a base class and a derived class, the way it's implemented is that the base class is allocated as part of a larger block with the derived class, but the blocks don't necessarily align. So if you have a pointer to the base class object, and you want to cast it to the derived class, your pointers are not aligned. Likewise, if you have a pointer to the derived class and you want to convert it to a pointer to the base class, they're not aligned. So in C++, there is a bunch of casts. There is the dynamic cast, static cast, const cast, reinterpret cast. No, I think that's about it. So depending on the circumstances, different casts that do the clever thing if you're working with objects. Okay, that's enough talking for me. If you're interested in this stuff, do the exercises, mail me if you have trouble with it. And I'm calling it a day. Jason, were there any deep questions? No. Okay, yeah, that's it. Somewhere in the beginning of the slides was the link to where you can find the whole textbook, so you can read this stuff in actual sentences and more exercises. This is based on the, sort of based on my Introduction to Scientific Programming class. TAG also has a parallel programming class every spring and a scientific computing class every fall. Okay, that's it. Thank you very much for coming here. People online, thank you for sort of keeping up with us. Yep.